Alright, so this reviewing for today's quiz. Okay. Is this point, -2, 5, -1, a solution to the following system? Okay. How do we know if it is a solution? So I didn't have to use substitution or elimination. Remember, anything from Unit 4 is fair game on these quizzes, so maybe it's a good thing I put some of this stuff on the review. But they already did the solving. They did the substitution or elimination, and this was the solution they got, and this was the system they had started with. How do you check to see if this is a solution to this system? Plug it in. So we'll label these A, B, and C. We plug it into A. We have -2 plus 5 plus -1 equals 2. I'm going to type the left side in my calculator and pretend the right side doesn't exist. So I have -2 plus 5 plus -1, and I get 2 for the left side. So I have 2 equals 2. Did it work? So is it a solution? It is? I'm done? No. Why am I not yet done? I have to do it for all three, so now I have to move on to B. So B, 2 times x minus 4 times y plus 3 times z equals -27. Notice I didn't fill them in yet because I put parentheses around everything. Here's where the x goes. The x was -2. Here's where the y goes. The y was 5. Here's where the z goes. The z was -1. Pretend the right side doesn't exist. Type in the left side in our calculator. So go ahead and do that now. I got -27. Did it work? Yeah. Am I done? No. Nope, I still have to do it for C. So C is x minus 3y plus z equals 18. Where the x goes, I have a -2. Where the y goes, I'll have a 5. Where the z goes, I'll have a -1. Cover up the right side. Let's type the left side in our calculator. What do we get when we type this one in? Number 2, what'd you get? I got -18 also. So I have -18 on the left equals 18 on the right. Is that right? No. That does not work on that one. Okay? So we still have to answer, is this a solution to the following system? What's our answer going to be? No. It did not work for all three. If I got a yes on that very last one, I got another check mark, then I can answer yes. But in this case, I did not get check marks on all three, so I have to answer no. And if that would have happened first, it would have been even easier because I wouldn't have had to do the other two. As soon as I have one that doesn't work, I know it's not the solution. Okay, that means whoever did this problem needs to go back and find their error because more than likely they did their substitution or elimination wrong. Okay. All right, so number 2 says to write a system of 3 equations with a solution of 5, 3, -1. I'm going to show you how I write your guys' problems. I know that I need 3 equations. I'm going to write out A, B, and C. I'm going to come up with any combination I want. Maybe I'll do 2x. Maybe I'll do -3y. Maybe I'll write plus z equals. There's my combination. Okay? Cool. I have one equation almost done. Okay? write a B and write a C. It doesn't matter how you write them. So if I write another one, maybe I make it really simple and do x plus y plus z equals. I don't write what they equal, though, because that's the important part. Okay? But make up a third one on your own. Make up one. Anything you want. Have it have an x, have it have a y, and have it have a z. It can be any combination. You can put whatever coefficient you want. You can do whatever you want with plus and minus signs. And then number 8 is going to tell me what he came up with. Ready, number 8?
Yeah.
What'd you get?
3x plus y plus z.
Perfect. It does not matter what you come up with. Whatever you do works. Okay? Because we don't know what any of these equal. But we're going to figure out what will make it work. If I plug in 5, 3, negative 1 to these equations, I just have to make them true. So I'm going to take my A equation. I'm going to plug in 2 times x was 5 minus 3 times y was 3 plus z was negative 1. And I know that when I type that in, I get 0, so I want this side to be 0, because if I plug that in, I know that equation is now true. Kind of cool? That's actually how I write your guys' problems. Try it for B. What do you get when you add x plus y plus z? Number 11 is going to tell me what they get. What did you get for that B one? You got 7? I got 7 also. Okay. Now we all have different C ones, so go ahead and do it for your C. Number 8 is going to tell me what he gets for this C, because I took his. What'd you get? 17, cool. We wrote a system. Now you could use substitution or elimination and make someone else solve it. That's what I do to you guys all the time. I make up a system just like that, and then I tell you have to use substitution or elimination to solve it. And we'll get this as our answer, or we should. So if you ever need extra practice with this, you guys know how to write a new problem and practice it. Okay. Find the given element using the following matrices. So it looks like they gave us a matrix A and a matrix B. Okay. Number 12, what matrix are we going to look at for this one?
I got 4.
Okay, wait a minute. Am I using matrix A or matrix B? A, okay. And then what do I do?
You go down 3.
Down 3.
And
Over to the second one, which is 4. Very good. Okay. Number 15, tell me how to do number 4 here.
we go to the first row.
Okay, first row
To the second column.
to the second column. And which matrix am I looking at here?
B.
So first row, second column is negative 10 here. Does that look okay? Looks good to me. Let's talk about dimensions. What are the dimensions here of number 5? Number 16. What are these dimensions? Very good. This is a 3 by 2. And number 4, what are the dimensions of number 6? 2 by 1. Make sure you're comfortable with finding dimensions, because it's going to make our life when multiplying a lot easier. Okay, number 7. How do I do this one, number 3? You multiply what? you multiply the negative 4 by each element on the inside. So, negative 4 times negative 1 is a positive 4. Negative 4 times 2 is negative 8. Negative 4 times 4 is negative 16. Negative 4 times negative 3 is a positive 12. Negative 4 times negative 1 is 4. Negative 4 times 7 is negative 28. So far, so good. How do we do number 8? How about number 5? How are we going to do number 8? When we add matrices, what do we need to do? You can't do that one. That one's undefined. So you can write undefined or not possible. Remember, there's 3 things that you need to write when it's undefined. One, you have to tell me that it's undefined. What's the next thing we have to write? What should we write out? What is it? Why it's undefined. Yep, the explanation. And there's a third thing that we need to support the dimensions. Very good. Yeah, we only need our dimensions here. So I'm going to write them out. This is a 3 by 3 plus a 2 by 3. Why is it that we cannot add a 3 by 3 plus a 2 by 3? This one has a different reasoning than the multiplication. Why can you not add or subtract if you have a 3 by 3 plus a 2 by 3? How do we add matrices? Yeah, you have to have the same dimensions. So it's undefined because why? They don't have the same dimensions. Okay? It's undefined. They do not have the same dimensions. That's why we have to write out the dimensions, because we're showing that they don't have the same dimensions. Questions on number 8? Can we add number 9? Yes, we can. Those have the same dimensions. How do we add matrices? How about number 2? How can we add matrices?
You add in the same spot.
The numbers in the same spot. So you take the 1, you add it to the negative 2. You take the 0, you add it to the 7. Okay? Our answer is going to have the same dimensions as what we started with in both of those. So 1 and negative 2 makes negative 1. 0 plus 7 is 7. 0 plus 3 is 3. 1 plus negative 2 is negative 1. Give me a 1 to 5. How do we feel about adding matrices? You guys rocked that out last week. Cool. How do I subtract them? Number 10. How about number 3? How do I subtract matrices? The same way, but this time we're going to be subtracting. So what's 5 minus 8? What's 1 minus 1? And 7 minus 0. So our answers are going to be the same dimensions, the 1 by 3. So 5 minus 8 is negative 3. 1 minus 1 is 0. 7 minus 0 is 7. How does that look? Number 7, are you good? Number 7. Are you good with that? Did you accidentally add them?
Yeah.
Okay. Yeah, I saw you erasing stuff. I want to make sure we figured out. Yeah, so subtract. Remember to subtract. Remember, some people like to rewrite their subtraction problems to make them addition problems, and you can do that too. You could have left the 517 alone and changed it to plus a, make all these negative. Negative 8, negative 1, 0 doesn't become negative. And then you add 5 and negative 8, still makes negative 3. 1 and negative 1 still makes 0. 7 and 0 still makes 7. So you can do it that way too. Some people prefer that way instead of adding, or instead of subtracting, they want to add. So that's okay too. Are we ready to flip this over? All right, number 11. If people lost points on last week's quiz, it was usually either here or when they were describing the undefined. So, how do I do a problem that has numbers out front of the matrices and we have two things that are going on here?
Multiply the number on the outside by the number on the inside.
Yes, take the number on the outside and distribute it to everything on the inside. Do I distribute a 2 or a negative 2 to this one? You can distribute either way. It depends. Do you want to subtract or do you want to add? If you want to add, distribute the negative 2, so this changes to plus a negative 2 times this. If you want to subtract, then only distribute the 2. Which one do you guys want to distribute, a 2 or a negative 2? Negative 2. Okay, here we go. The 3 distributed to the first one, plus negative 2 distributed to that one. So I'm going to change this to plus a negative 2 here. Okay, the 3 distributed becomes negative 6, 18, 24, negative 12, negative 9, 3. And remember, all this is stuff that you can do in the calculator. So 3 times negative 2, 3 times 6. So if you get stumped on that multiplication, just use your calculator. Okay. Plus, we're going to distribute that negative 2. So negative 2 times negative 1 is a positive 2. Negative 2 times 1, negative 2. Negative 2 times 2 is negative 4. Negative 2 times 6 is negative 12. Negative 2 times 5 is negative 10. Negative 2 times 4 is negative 8. Now we can add these just like we did on the front page. Negative 6 plus 2 is negative 4. 18 plus negative 2 is 16. 24 plus negative 4 is 20. Negative 12 plus negative 12, negative 24. Negative 9 and negative 10 is negative 19. 3 and negative 8 is negative 5. And that one should be all good. Try number 12 on your own. Okay? Try number 12 now that we did number 11. How did we do? Give me a 1 through 5. I got that one. I got most of it, but messed one of them up somewhere. Just something silly. Maybe just one of your elements was messed up. Where are we at? Okay. So, first distributed the negative sign. Each thing becomes the opposite. Then I kept the plus sign, I distributed the 4. Got all those numbers. Then all I was doing was adding 2 2x2 matrices. All right, do you have questions on that one before we move to 13? No? Okay. So number 13. What are we doing in number 13? What operation? Multiplying. So we're going to have to start by writing out the dimensions to figure out, can we even multiply? What are the dimensions of the first? 2 by 2 times, what are the dimensions here? Can I multiply them? Look at those inside numbers. Can you multiply these? Yes. What is your answer going to be? Remember, take out that middleman, and that tells you the answer. The dimensions of your answer, so a 2 by 2. So I know my answer, I'll write it right here when I eventually get it, will be a 2 by 2. Okay. But remember, we're going to draw a giant workbox. And what do we circle in the first one, rows or columns? Row. And as Mrs. Steffi says, row, row, row your boat across the stream. You don't want to go down a waterfall. Okay? So we have rows in the first. We're going to use columns then in the second. So across the top row, what are the two numbers? 0, 2 goes in every box across the top. What are the numbers in the bottom row? Negative 2, negative 5 go in every box across the bottom. Okay, let me switch numbers for those switch colors for the columns. So I'll use green. In the first column, what two numbers do we use? 6 and 3 go in every single box. In the second column, the two numbers we use are negative 6 and 0. Negative 6, 0 goes in every box. Remember, sometimes in this one we only have 2 pairs of numbers because there was 2 numbers circled. If we had 3 numbers circled, you'd have 3 number pairs there. If you had 4 numbers circled, you'd have 4 number pairs there in each box. Okay? So then, we are adding the pairs up. So equal, have a second workbox, and now we can use our calculator and do the multiplication if we need to use our calculator. Or maybe you can do it in your head. 0 times 6, 0 plus 2 times 3 is 6. 0 times anything is 0 plus, oh, that's 0 also. Negative 2 times 6 is negative 12 plus negative 5 times 3 is negative 15. Negative times a negative is a positive, so 2 times 6 is 12. Plus, that's multiplied by 0, so that turns into 0. Now we can add those numbers up. Again, you can use your calculator if you want. 0 plus 6 is 6. 0 plus 0 is 0. Negative 12 and negative 15 is negative 27. 12 and 0 is 12. So there's your final answer. Give me a 1 to 5. I feel really good about doing that multiplication on my own. All right, let's try the next one. Number 15, tell me the dimensions of the first one. 2 by 1 times, what are the dimensions of the next one? A 1 by 2. Can I multiply these, number 16? Yeah. I look at those middle numbers, I see but matching 1, so I take out that middleman. What's my answer going to have as dimensions? A 2 by 2. So I'm going to write my matrix here where I'm going to write my answer eventually, which is going to be a 2 by 2. I'm going to write my workbox here, which I know is going to be a 2 by 2 workbox. Number 12, what do I circle in the first one? The 6. And what else? The negative 3, because I circle rows, and the rows just have one number in them. What do I circle in the second matrix? Number 7. Negative 5 and the 4. I'm circling columns, and they're lonely numbers. So, across my top row, what number goes in each box? The 6. Let's cross the top row, I have a 6, so I just have the one number 6 in each of those. Okay. Across the bottom, what numbers go in each of these boxes? The negative 3, the negative 3. All right, first column is a negative 5, so we put the negative 5 in all of those. And in the second column, I have a 4, so it goes in both of those. I actually don't need a second workbox there because there's nothing to add. So I'm going to go right to my answer here. 6 times negative 5 is negative 30. 6 times 4 is 24. Negative 3 times negative 5 is a positive 15. Negative 3 times 4 is a negative 12. And that should be your final answer on that one. Questions on that one? How do we feel about that one? 1 through 5, where are we at? Good. All right, we ready for 15? Number 3. What are my dimensions here in number 15? A 3 by 2 times a 2 by 2. Can I do that? And what is my answer going to be? A 3 by 2. So I'm going to write out my work box here. I'm going to kind of make it long and narrow. That's okay though. 3 by 2 is my work box. Okay. What do I circle in the first one there, number 2?
0 and 5.
The 0 and 5 get circled. What else?
Negative 3 and 1.
Negative 3 and 1. What else?
And then negative 5 and 1.
Negative 5 and 1. Where do the 0 and the 5 go?
Across the first.
Across in that top box. So 0 and a 5, a 0 and a 5. I'm going to write them next to each other instead of on top and bottom based on the room I have. That middle row, the negative 3 and the 1, go in my middle row. Negative 3 and 1, negative 3 and 1. Across the bottom, I have negative 5 and 1. Raise your hand if you can get that far, if you can write in that work box. Good. Okay, so then what do I circle in my second matrix there? Number 8, what do I circle?
Negative 4, negative 2.
And where do those numbers go?
Down the first column.
Down the first column. So this one matches with negative 4, this one matches with negative 2. This one matches with negative 4, this one matches with negative 2. And then I have that plus sign in between each pair of numbers. How about number 15? What else do I circle in that second matrix? Number 15.
4 is
And where do those two numbers go?
in the
In the second
second column.
column. So I have a 4, negative 4, 4, negative 4, 4, negative 4. And then remember that you're adding each of these. If you have a scientific calculator, you could go through and type in that whole thing and get right to the answer box. I don't like to do that. I like to do the multiplication and then add them, because that's just me. But it does not matter. So in this box I have 0 plus negative 10. Just doing the multiplication here. I have a 12 plus negative 2. I have a 20 plus negative 2. Here I have 0 plus negative 20. Negative 12 plus negative 4. I have a negative 20 plus negative 4. Then I go and I add them up. 0 and negative 10. Negative 10 in that first row, first column. 0 and negative 20 is negative 20 in that first row. 12 and negative 2 is 10. Negative 12 and negative 4 is negative 16. 20 and negative 2 is going to be 18. Negative 20 and negative 4 is negative 24. How do we feel about that one? You doing okay with that? All right, number 16. You guys already tried 15, 16, and 17. I gave you guys those ones ahead of time to do. Okay. Can we multiply these? Can we multiply 16? The two matrices there? What is our answer going to be? What dimensions? A 2 by 2. So this one was a 2 by 3 times a 3 by 2, and we get a 2 by 2. Let me create my giant workbox here. When I go to circle numbers here, how many numbers am I circling in each row and each column? How many numbers are circled here? 3. So we're going to have 3 pairs in each of our boxes then. So in our boxes across the top, we're going to have 5, 3, and 5. 5, 3, and 5. What numbers do you have in the boxes on the bottom? 1, 5, 0. Okay. In that first column, You have the numbers -4, -3, 3. And in the second column, we use numbers 2, 4, and -5. 2, 4, and -5. You guys did the setup already for this. Raise your hand if you were able to come up with that setup when I had you guys try these on your own. Okay. So, I'm not going to do the next box because you guys already tried these. You should have gotten that far. Or you could just type this right into your scientific calculator as it's written as it is. And you end up with -14, -3, -19, and 22. Did that look right? Raise your hand if you got that. A couple people did good. Okay. You just have to be careful when you are doing those setups. Okay. Number 17. Number 5, what are the dimensions there? A 2 by 3 times a 2 by 3. Can we multiply these? No. If you look at this number and that number, they do not match. So what do we have to write here? Number 4, what are we going to write? Undefined. And what's my reasoning going to be if I write undefined? Yeah, the columns in the first do not match what? The rows in the second. Good. Good, good, good. All right, how about number 18? Can we do that one? What's our answer going to be for that one? A 4 by 3. So we had a, I'm going to write it up here, 4 by 2 times a 2 by 3. So our answer has to be a 4 by 3. Okay. Oh, this is going to be a big one. In the top row, what two numbers are going to be in each one of those? -2, -6. In the next row, we have -4, 3, -4, 3, -4, 3. Next row, we have 5, 0. Next row, we have 4, -6. First column, what numbers are going to be paired with each of those? 2, -2. Okay. In the middle column, what two numbers are we pairing? -2, 0. And in the last column, what are the numbers that we're going to pair it with? 2, -3. This is the hard part, guys. This box here is the hard part. If you can fill that out, then you can do the rest. Because the rest is just calculator work. Okay, if I type this into my calculator, again, you can type it in all at once if you wish. We had -2 times 2 minus 6 times -2, or plus -6 if you want to write it that way. And we can see that that number is 8, So 8's going to go in that first spot. Okay. Negative 2 times 2 plus negative 6 times 0. Negative 4 goes in that second spot. Negative 2 times 2 plus negative 6 times negative 3. 14 goes in this last spot. So you can type them in your calculator all at once if you wish. Or you can do that second workbox and show me the numbers that you're going to be adding. In the next row, we are going to get negative 14, 8, negative 17. Next row is going to be 10, negative 10, 10. And in the last row, 20, negative 8, 26. Okay. Number 19, can we multiply these? We have a 3 by 3 times a 3 by 2. What's our answer going to be? A 3 by 2. I know this answer without doing any work. Why? I can go and do the work. What, one of you? Go ahead. Yes, this is called the identity matrix. Okay, remember, if you see the ones on a diagonal and it's a perfect square matrix, that's called the identity matrix. What's our answer going to be then? This same thing. So we have 2, 7, 5, negative 6, negative 4, negative 3. If you want to not show work, you have to tell me that this is the identity matrix and then put your answer in. If you don't know what this is called, then you're going to have to show your work and show me that you get the same thing. Okay? But you have your notes, so if you write this down, that should help you. Number 20. Is our answer the same thing? Because again, I see the identity matrix. $15, what do you think? Why?
Because the 2 then is 3 by 3.
You have a 3 by 2 times a 3 by 3. These do not match, meaning your answer is undefined. You cannot automatically assume, because you multiply by an identity, that your answer is this. You have to first see, can you even multiply them? This one's undefined because the columns in the first do not match the rows in the second, which we showed with writing out our dimensions. All right.